All right, welcome. This is Kistner, coming back here with 8.5 irrational variation equations. The notes are going to be fairly quick today because as you're watching this, I need to start getting ready for my trip to Boston. So my class will have a sub Friday morning when you go over these problems, but Mr. Young can always help if need be. We did variation equations last chapter. That was our last section. We had two types. We had direct, and another word for that's proportional. Or we also had inverse. So you can say things are directly proportional or they're inversely proportional. A direct proportional is simply this. It'll look like y equals. Our k is still there. It's still our constant, x. And instead of having a normal exponent like squared or whatever, since we're dealing with irrationals, it'll be a over b as our exponent. And if it's inverse, you can probably guess what it'll be.
We have one correction to the announcements.
Sorry about that. It'll be y equals k over x to the a over b. So we need to write down some steps here. There's 3 steps that we need to go through every time. The first one is we're going to find k, and we'll give you information to do that. You plug in points and you'll do that. Once you find k, you write the particular equation. And then we answer. Our last step will be answer any other questions. Okay, so let's look at an example here. So our example here will be the area of an egg's shell is directly proportional. Let me see that so you can see that. Move it so you can see it here. Directly proportional to 2/3 the power of the mass of the egg. Suppose that a normal 60-gram chicken egg has a shell of 28 square centimeters. So first thing I have to do is define variables. We should always define variables so when I use them, you know what I'm talking about. So I'm going to let S equal the number of square centimeters. And I'm going to let M equal the number of grams, because M for mass. All right. Now, we need to first write our general equation so we can solve for k. Our general equation here will be S equals kx, and it's directly proportional, so we're going to write 2/3 power. So now we need to plug things in. I shouldn't have used x, should I? Should have used M. Okay. Don't know why that was red, but oh well. Now, we need to plug in some points here. We know that M is 60 grams, square centimeters is 28, so I know my equation will be 28 equals K times 60 to the 2/3. All right, so now we take this 60 to the 2/3. So the first thing we've got to make sure we know that it's just the 60th raised to the 2/3, and to get k by itself, I just simply divide off by 60 to the 2/3. That's not going to be a nice, pretty number, so I'm going to leave it written as 60 to the 2/3, and you'll see why in a little bit. If we type this into a calculator, we'll get a weird number, and I don't want to round yet. I typically want to round at the very end here, or the last that I can. So what we're going to do is we're going to say that k equals 28 over 60 to the 2/3. And we're going to substitute that back in. I'm going to leave it like this, because that's as accurate as you can get it. So if I bring up my calculator here, I'll show you what I mean. If I do 28 divided by 60 to the 2 divided by 3, close parentheses, I get this weird decimal. I don't want to write this thing out, and this is actually being rounded to the 9 places or something, and I don't really want to have to write that out every time. So it's much easier just to write 28 over 60 to 2/3. So when I write my particular equation, it'll be S equals 28 over 60 to the 2/3 times M to the 2/3. There's my particular equation. If this had worked out to be a nice, neat number, of course, we could substitute it in there. Now, one shortcut that we can always do is this. Once we have this number, or actually, let's just do this. If I type this back in, if I do 28 divided by 60 to the 2/3 again, and I'm not going to hit enter. What I'm going to hit is this STO button. And I'm going to store it to I'm going to hit alpha, and I'm just going to hit Y, hit 1, hit enter. So now every time that I hit alpha Y, that number comes up. So if I need to plug that into my calculator, I don't have to type in 28 over 60 to the 2/3 every time. I can just plug in Y, and that'll be a nice little way to do it. So I want to use this to predict something. Let's predict the surface area. Predict surface area of a, sorry, don't put equals, of an egg. Let's see, that's 1,600 grams. Okay. So here's our mass. We want S. So we're going to say S equals 28 over 60 to the 2/3 times 1,600 to the 2/3. And we can go back up here and type this in. We can go alpha Y times 1,600 to the 2 divided by 3. And we get 249.92, and we'll just leave it at that. And that'll be centimeters squared. Hold on just a second. So that's a very brief example, and obviously if we were going to solve for m here, let's do one example of that. Let's say that I know that the area is 0.6. I know S equals 0.6. What's the mass? And these are just very informal notes here. I'm not writing out the full problem. So what that tells me is that 0.6 has to equal our 28 over 60 to the 2/3, or our Y in our calculator. That's you start to see why we like to store it as Y, times m to the 2/3. So I have to get m by itself. So I'm going to divide by this, by the constant over here, which is 0.6 divided by 28 over 60 to the 2/3. And that's going to equal my m to the 2/3. And the last thing I have to do is think about how do I get the 2/3 power off this m? Well, the easy way to do that is to come through and raise it to the 3/2. If I raise both sides to the 3/2, then the 2/3 will cancel. 2/3 times 3/2 is 1, and I get m by itself. So I'm going to come over here to calculator and say it'll be 0.6 divided by, well, let's start out by putting in parentheses. I made that mistake. Let's go 0.6 divided by, and remember we've already stored it to alpha Y, raised to the 3 divided by 2, hit enter, and we see that it's about 19 grams. So we're gonna leave it as about 19 grams. So m equals 0.19 grams. So there you can see that by plugging into the calculator and not rounding, we will all end up getting the same number. If you start to round and then the person next to you is not rounding yet, we might end up getting different answers. But we don't want that. We want to all be able to get the same answer. So we don't round until the very, very end. All right. So those are your notes tonight. They're nice and short. We'll work some problems in groups in class. At least my class will. I don't know how Young's going to do it. But other than that, we'll see you guys tomorrow morning, and have a great night. This is Kistner, out.